Hello everyone, welcome to the second session for these functions. Now we started to solve question 5. It's a parabola and an exponential function, as you know, and we had last three questions 5.8, 5.9, and 5.10 left. So let's just remember the question 5.8. It says for which values of x this condition satisfied. Now, what's that condition? It is product of two things. Now, and we want it to be more than 0, which is positive. So to be able to have this product, we must have both functions at the same time to be positive, or they must be both at the same time to be negative. Now, what does it mean f of x positive? It means the function is above x, and negative means it means that function, the line is below x, lies below x. The first one actually is not the function g of x, it's what? It is the derivative of g of x. We don't really need to take the derivative of g of x anyway. However, we must know the meaning of what happens when derivative is positive and when derivative is negative. So derivative positive means that function is increasing, and negative means that function is decreasing. So basically, we will be looking for, using the graph, we will be looking for whenever g increase, at the same time, we must have f above x, or the other condition, whenever g of x decreases, we must have f below x. So that was the question we stopped. Let's have a look from the diagram, the graphs. F of x is the one with exponential function, okay? And as you see, f of x is always above x. So we don't have any option of f of x being below x. So that's why what I will write for the first one, for the one which is the case when f of x below x, I'll just put NA. You see, on the bottom, I just put that. The reason is why? Because f always above x. So we can't have any solution from that condition. Okay, that's not possible. The first one we will be looking for. So when f above x, which is always, now we'll just be taking the part whenever g of x increases. So g of x, if you look above here, the parabola is increasing, it's decreasing, and then after turning point, it's increasing. So it increases after 1.2. So that will be the answer then. Our answer is going to be whenever f of x is more than or equal to 1/2. So we can just highlight the answer. So you don't need to explain all these things. You will be just writing the answer in such questions, but to be able to write that answer correctly, you must know the meaning of this product and how to look at the graphs given. 5.9, use the graphs to determine the values of k for which f of x is k will have non-real roots. Now, f of x is equal to k. So remember, in such questions, we will be thinking the right side of this equation, which is k, is like a function, is like a horizontal function. Like it's like g of x is equal to k, a horizontal line. So a horizontal line, or we can say horizontal function. So non-real roots means it doesn't have any solution, and no solution means those functions or those lines do not intersect. Non-real roots means no solution, and in the meaning of graph, it means no intersection. Okay, no intersection. So f and g should not intersect in our case. Or in other words, a horizontal line we draw shouldn't cut f of x. So what kind of a horizontal line do not cut f of x? Remember, f of x was a happy face like that. So we can draw many possible horizontal lines. We can draw a horizontal line which cuts twice. We can draw a horizontal line which touches only once, or which we are looking for is we will be drawing a horizontal line in this case which doesn't touch, which does not have any intersect. So that's like a two solution, that's one solution, and that's no real solution. Let's say NRS, no real solution. And that's what we are looking for from the graph. So no real solution is that line here. So which lines satisfy this condition? The lines which are below turning point, isn't? Because if the horizontal line above turning point, then it will be touching twice. If it is equal to TPY, then it will be touching only once. So the answer is going to be whatever the y values, which is the k values in this case, must be below the turning point of this function. So just look at the graph. What is our turning point? It is negative 1.5 and 0. It's actually x-axis is our turning point. So whenever we have a line which is below x-axis, and that, how can we write that? We can just say k must be less than 0. It is not even, it shouldn't even be equal to 0. Okay, it must be definitely less than 0, and that's my answer. So we are just looking the graphs and thinking what are we looking for, what we are focusing and whatever, and then writing the answer. That's it. And 5.10, write down new function f if the graph f is shifted 2 units left. Okay, 2 units left. Which was the graph of f? It is k to the power of x, which was 4 to the power of x. Okay, so we have 4 to the power of x. So if you move it k units left, what will be the new function? 4x plus 4 units left. If it is like 2 units right, it is x plus 2. If it is up, remember 4x plus 1. So if it is down, I can say 4x minus 3. Okay, so the one we are looking for is the first one, that is 4 left. The second one was 2 right. The third one is 1 up, and then the last one was 3 down, you know that. And in this case, the answer is going to be first one, 4 to the power of x plus 4. Okay, so this was the parabola and exponential question combined. Oh, sorry, actually the question says only 2 units left. So my bad, we can just write 4x to the power of, let's write the answer down there then. So it's going to be y is equal to 4x plus 2. That's the answer. Okay, because it just says 2 units. All right, now our next question, question 6 from the same paper. This time there's a parabola, and we ask to find inverse function of this parabola. Now, parabola has inverse function of this idea. Remember, it is like bird and fish condition. Now, the method to find inverse function, a general way, is you write y is equal to negative x squared and swap x and y. That's 1 mark. So instead of y, that means instead of y, write x wherever in the graph, in the function, and wherever you see x, substitute with y. So that's the idea, like swap x and y values. And then the thing we will be doing is leave y alone. So how do we leave y alone? Then we must get rid of the negative sign in front first. So we can write y squared is negative x. And finally, we have to root both sides, which is y will be plus minus. Okay, that's the critical part, negative x. Now, first of all, we should not forget that plus minus. And secondly, that negative x should not confuse us. Nothing is wrong with negative x. Because, you know, inside a square root, inside even powered roots, we must have positive numbers for a real number to get a real answer. So negative roots, if there's a negative number inside an even root, then that will be not real. That's a complex number anyway. Now, but if we have root negative x, that means to be able to have negative x values positive, x itself should be negative anyway. Okay, that's one thing. So there's nothing is wrong. Like, remember, just imagine if x is negative 4, so it's negative 4 because x is negative 4. So negative 4 is 4, so it's fine. I am fine with negative 4 in this case. When x is negative 4, any negative x value, we don't have any problem with that. So that's actually the domain of this function. We must have x values negative. And in the case of that plus minus, I told you should not forget it and keep in mind. Okay, that's important, but we have to choose one of them. That's the idea of restricting domain when there is a inverse parabola questions. Now, the domain, the function is already given, the parabola, and its domain is already restricted. They are not asking restricted domain or whatever. They already given us the restricted domain. Okay, restricted domain is given. We cannot take x anything. Actually, remember, if for a parabola, normally we don't have any problem with domains. I can say XR, X can be any real number for any parabola. However, when we need to find its inverse, we must restrict it so that inverse of that function becomes a function as well. Okay, now the last step. We have done all these, you swap X and Y, you leave Y alone. Last step, we have to choose one of those plus or minuses. And it all depends on what was the restricted domain, what is the restricted domain given. So it is given as X positive, so we choose the positive one. If it were negative, we had to write negative root negative X. Okay, but in this case, I will write as the final answer root negative X. That's it. So if it were, again, let me repeat myself, if it were negative X for the restricted domain of parabola, I had to choose the negative option. But because it is positive in the restricted domain, we choose the positive one. Now determine the equation of F reflection of G. Okay, let me just, they didn't ask to draw, but let me just have a quick drawing of these graphs so you may have a better understanding. What is that? We have we have negative X squared, and for the positive X values, so it is like that. Oh, sorry, it is going to be something like that. You see, this will be the graph of G of X. It's negative X squared. So like if you have 2, for example, 2 will give you negative 2 squared. So negative 2 times negative 4. Okay. And just remember that difference as well. Negative 2 squared is not same as the square of negative 2. They are different. Negative 2 squared is negative 4. Nothing is wrong. But square of negative 2 is 4. They are different. So in this case, we have that negative X squared. So that's why I can actually say negative X squared is not same as square of negative X, because square of negative X is X squared. They are different. Okay, just keep that in mind. Now, how will be the inverse graph? The inverse graph will be, first of all, it will be the reflection about y is equal to x. So let me draw that line, y is equal to x line. Okay, so that's good. I have the y-axis, I have the x-axis, and that's my y is equal to x. So the reflection of this is going to be, that's why, like a bird. So that's the inverse of this function. And if I need to show a point, I can just swap the coordinates. I had 2 and minus 4 on G, and the inverse will have minus 4 and 2. Okay, that will be the inverse graph. So I have the G of X, and its inverse can be drawn like that. And domain and range of those functions swap as well. So yeah, and it is reflected about y is equal to x. All the points, the x, y coordinate swap, that helps us drawing. That's how we drew actually. No, so that was, they didn't ask to draw or anything, but that's in case they ask, in case you are dealing with such questions with including the graphs, just keep that, bear that in mind. Okay, so yeah, the domain and range swap and all good. Now reflection, F is the reflection of the graph G of X about x-axis. So we are looking for a new function which will be reflection of this thing that we got about x-axis. What happens if the graph is about x-axis? It will just change the sign, the whole thing. So let's just write the answer straight. We can say f of x will be negative of negative of the thing, which is negative root x. That's the answer. Just 2 marks. Okay, you'll just put negative in front. That wouldn't be a much big problem. But I would just want to mention this domain and range on that space. So we have G of X, let's say, and the inverse. So we may not have chance to go through this again. So let me just in this question mention that. Let's say, let's draw a quick small table to write the domains and ranges of such graphs. So the first one, I will write domain, so that's D, and then the second one will be range. So what will be the domain of G of X? So that's restricted domain. Okay, X is more than or equal to 0. And the range values, because X squared is always positive, Negative x square is always negative then. So x square of anything is more than or equal to 0, always. Yes, but then if you times it by negative, then negative x square of something is always less than 0 then. So that's the thing. That is why g of x is basically always less than or equal to 0. That is my range. I cannot get g of x positive. You can see it from in the diagram. You see, it's always below x-axis when we draw g of x. Now, finally, how do we write domain and range of the inverse functions? You can look at the graph and say it, or you remember the idea that we just said, domain and range swap. That means the domain of original function becomes the range of inverse, and range of original function becomes the domain of inverse. So domain was x positive. So in its inverse, it becomes y positive. And range was y negative. Its inverse, it becomes x negative. As you see, G has all the points of G is plus and minus in the fourth quadrant. And all the points of its inverse are minus and plus in the second quadrant. That's the idea. Okay, now another question. We have a hyperbola and a straight line. Looks like we have two straight lines. There is F, there is G, there is H. Okay, two straight lines. All right, now the vertical asymptote line G is tangent at origin, and POT is 90 degrees. Okay, so let's just put there 90 degrees, that is given, POT, that angle. Anything else we know? So this line is y is equal to minus x, okay, and g of x is mx plus c. We don't know its equation. Actually, c is 0 because it passes through origin. That's fine. And what was f of x? F of x was, let me write it there, 3 over, okay, let's just write the asymptotes as you read. So it's going to be x is equal to minus 1, what makes the numerator 0. And this is y is equal to q. We don't know what q is. All right. Now, that's the first question, actually, find q. So how do you find a missing value from the graph? It's basically we can find it by substituting any point on the graph given. So is there any point given on the graph? On F, yeah, actually it's just origin. That's what we are going to do. We will substitute 0 and 0 in y is equal to 3 over x plus 1 plus q. So if you make the substitution, what do we get? It is 0 is equal to 3 over 0 plus 1 plus q. So from here we got q is equal to negative 3. Okay. So how is it negative 3? When we substitute 0 and 0, so you get x plus 1, good. And then because it's above x, and that's x is equal to minus 1, good. And horizontal asymptotes all are fine. So you get negative 3. Yeah. So that's kind of a mistake in the question. Basically, in a hyperbola, what's the mistake? It should be, let's change it as negative 3. See, because when you have a over x minus p plus q, remember we have two conditions, when a positive and when a negative. So when a positive and when a negative, there are two possible types of hyperbolic graphs. What are they? Let's just draw the asymptote lines and asymptote lines. When the value above x, above the fraction numerator is positive, the graph must be in the first and the third quadrants of the according to the asymptote lines. However, in this graph, it is other way around. And that's why I said a must be negative. And that's why I said the graph is wrong or the question is wrong. And that's why I changed 3 to negative 3. Okay, let's make my change in the solution. Then we can get the idea from the memo. So that's how we got q is 3. And that's now I can tell you the line is y is equal to 3. So otherwise it was something wrong if I say this horizontal line is y is equal to negative 3. That wouldn't be correct. Now it is correct when we change the question. Okay, don't change the question yourself in the exams. I'm just doing it by out of fun. Anyway, determine the equation of G. That's straight line and it's perpendicular. There's nothing much to say because we know the gradient of M is H is -1. So because it is perpendicular, the gradient of G must be 1. You can just say it. And because C is 0, you can just write the equation of G is y is equal to x. That's it. So one line is y is equal to -x. The other line is y is equal to x. They are perpendicular to each other. That's all. You don't need to explain anything a lot. It's just the gradient must be 1 because it's perpendicular. And since this gradient is -1, that must be 1 then. So that's how we find the gradient 1. And that's how we find the C, value of C is 0. Okay, and finally, oh, they ask an area of POT. Okay, area of POT. Do we know the coordinates of P? Yes, and the coordinates of T, not at the moment, but we can. Okay, because I know that line equation. So let's have the idea. What are the coordinates of P? It was -1 and 3. Okay, and what is the coordinates of T? It is again, so y coordinate is 3. That's the same because it's on the same line. Which line? It's on the line of y is equal to 3. This line is y is equal to 3. Remember? The line, the asymptote line is, so that's y is equal to 3. How do we get the x coordinate? So remember, we got the equation of G. The equation of G is y is equal to x. So since we know equation of G is y is equal to x, so that must have the same x and y coordinates. Any point on this line has the same x and y coordinates. So it's 3 and 3. Okay. Now, how can we get area of such a triangle? You can use many rules, but let's do the shortest possible solution. Like we can have a line here and another line, and we know they are perpendicular. Okay, my drawings may not be scaled, and yeah, we have this triangle. So if we focus the coordinates, it will tell us everything. So that first coordinate is what? -1. So -1 and 3. This coordinate is 3 and 3, and that coordinate is 0 and 0. So I can tell you that's my base. If I drop a height from here, it's perpendicular. So let's just say that's my base and that's my height. So area of a triangle is half height times base. So you just need to tell me what is base, the distance from -1 to 3 to 3 to 3. So it's actually horizontal distance. So you can just say 3 minus -3. You can actually just write the answer 4. And what is height? So what's the distance from 0, 0 to a point on it? What is that point on it? What is this line? So that line, I just said, all these points on this line has the same y coordinates, y is equal to 3. So that point is 0 and 3. So the distance between 0, 0 and 0, 3 is basically 3 minus 0. It's basically 3. So that's how I know the height and the base of this triangle. And that's then I can just get the area for this triangle then. So let's just write the answer. The answer is going to be area of POT is 1/2 times height times base. That's 6. All right. Okay, now let's check another question. That's another question 6. We have a parabola. It has turning point that we can see. Good. And there's a straight line, I guess. Yeah, it's a straight line. What else we know? QR is parallel to y-axis. Okay, that's a vertical line. We know the coordinates of anything. P is given. Yes, Q is given. Okay, all seems fine. Let me just write that function equation. It is given as y is equal to, in TP form, ax minus p square plus q. Okay, that's given. Let's up and see what's the first question. So the first question is asking P and Q. All right, you can just say it. P is negative. Oh, is it -3 or 3? You see. And what is Q? So because turning point is given, I can actually just write the function. So it's going to be a x minus, not minus, plus 3 square plus 1. So that is when I tell you the y coordinate of turning point is what? -3, and x coordinate of turning point was TPY is 1. Okay, let me just write that. We still don't know A. It's not the point. They're not asking A. So that's -3. And then TPY is 1. So then P value must be what? P value must be -3. And Q value is 1, just 1. See, that may be a small problem with writing P. You can say 3 or -3, just be careful. And then equation of G. So you see, to find A is missing. We need a point on the graph. So the point is Q. So that substitution method is a general method we can always apply. So we will substitute Q. What are the coordinates? 2 and 25. In which equation? In y is equal to ax plus 3 square plus 1. So when you substitute Q, so you'll get 25 is equal to, we still don't know A, 3 plus 3 square plus 1. Am I right? So we said 3 plus 3 square plus 1. Yes, so then 1 goes to other side, it's 24. And then A times 3 plus 3 square is 36. So that gives me what A is. So what is A? 24 over 36, which is 2 over 3. Okay, that was 4 marks. It's basically just substitute. And then the next question says find Tm. Well, that's a straight line question. Now, it's basically finding equation of a straight line. The thing is, like paper 2 question. Now, to find equation of a straight line, we must have given a gradient and a point. So, or we must find gradient somehow. Okay, we have a point. That's it, 7 and 0. But to be able to find gradient, we might be given an angle of inclination, or we might have a parallel line to this, or a perpendicular line to that, if we don't have 2 points. But if you look close and try to see, oh, we don't have parallel line, no angle of inclination, no perpendicular line. What? How can I get gradient so that I can find the equation of this line? Actually, do we know R? No. Do we know T? No, but we can get T, and that's good enough. You see, we can get T because T is y-intercept of both functions. I can find y-intercept of G since I know the equation of G at the moment. So I can find T, and using T, I can find gradient of Ts. And after Ts, the rest is easy. So then it becomes easier to solve that question. So what is the y-intercept of that function? To find T, T is the y-intercept of G and F, both graphs, okay, of G and H. So you substitute what was G, G of x, as we know, 2 over 3, x plus 3 square, what else? Plus 1. Now, what is G0? When you substitute 0, you get 9, so it is 6, so it's 7. So then I can tell you coordinates of T is basically 0 and 7. And you already know coordinates of S, 7 and 0. So that makes quite sense. So what's the gradient of ST? You can just say it's -1. So then let's write the equation of H. The gradient is negative, so it's -x. Y-intercept is 7, -x plus 7. So that is my equation of H. Well, actually, they ask T and M. Basically, they ask those coefficients. M is the gradient, T is the, so then we can just answer as what? M is the gradient, which is -1, T is 7. All right, next question, we ask to find QR. QR, that perpendicular length. Now it's the vertical distance, sorry, vertical distance, say that way. And finding coordinates of R is, that's what we need to do first. What is coordinates of R? So I know coordinates of R, actually I know the X coordinate must be 3, and I don't know the Y coordinate at the moment. But I get Y coordinate by substituting 3 into H, because it's on that function. You substitute X3 into the function of H and it gives you 4. So that's my Y coordinate. So that's how I can get coordinates of R is 3 and 4. And now on the top of it, there's this point Q, coordinates are 3 and 25. So what's the distance between these two? So if you know they have the same Y coordinates, the distance between two points, two such points in this vertical distance, vertical line is going to be difference of their Y coordinates, which is 25 minus 4. So I can just say QR is 21, 24 minus 4, 21 units. Okay, that will be the answer straight. 6.5, it says turning point of negative G plus 5. Now, can we write this function? Of course we can. You don't really need to, but we can. When you rewrite this function, negative G of X is basically reflection about x-axis. So the whole graph becomes upside down. And then when you plus 5, so it's shifted up. Now, when you reflect it about x-axis, x coordinate of turning point doesn't change. So remember, the graph was in this way. So it's all becoming in a way that below x-axis. And then you add 5. Let's do it anyway. Let's write the new function. I have the function above, so I can quickly change it. So what is P of X? It is negative 2 over 3. It's X plus 3 square plus 1. That is negative G of X. And then there is plus 5. So it is plus 5. So as you see, we have the turning point TPX hasn't changed, but TPY has changed. So TPY has become 6, not 6. Let me make a correction, because when you put negative, it's the whole thing become negative first. So it's negative 1. Okay. And then there is plus 5. So just be careful. This negative 1 over 2 x squared and negative 5, or negative 1 is basically negative x. Okay. So that negative G of X. So negative G of X is you change the signs, not the sign of the thing inside bracket, because that negative you put in front is enough. That's like the whole thing is negative, and that plus 1 become negative 1. Then we add plus 5. So from here, it's kind of easier to write the coordinates of turning point. What's the new turning point? It's minus 3. That's what we were saying. It doesn't change. Minus 1 plus 5, which is 4. So minus 3 plus 4 will be your answer, only full marks. You don't need to write the function. All right, and 6.6 have two unequal roots for G of X. Now, the same question, remember, we had done. We have this graph of G of X, and we have its turning point. What was turning point? Minus 3 and 1. And to be able to get two unequal real roots, that means two real roots, it means two solutions, and it means two intersections. So when do you get two intersections? When you draw a straight line. So what possible lines we can draw? We can draw a line which touches twice, or we can draw a line which touches once. We can draw lines not touching. So any line below turning point does not touch. And any line above turning point, we are all good with it. So what lines are that? You see, which lines we want to have. Those are the lines we are busy with. So if k is equal to 1, then it only touches once. But I want to have k, that's the answer coming now, more than 1. It doesn't just say real roots. It says unequal. That's why I can't take 1. I have to say k must be more than 1. Okay, so that was a parabola and a straight line question combined. Now there's an exponential graph which will have inverse function. So looks like a standard question, but let's try it anyway. To find, we can do it quick. To find any unknown again, what was the point? You substitute that point into the function. So you say 4 is equal to a to the power of -2. Now, how can you leave a alone to find it? We can take as a method, okay, that's not like you have to do this way. This is one of the ways. We can take the power of each side, and it's the power to the power. To be able to have the power of a 1, I will multiply it with 1/2. So both sides I'll take the power of 1/2. So then I can tell you a is 4 to the power of -12. So I mean, you can use calculator. It will give us 1/2, or you can just use it is 1/4 to the power of half. So which is 1/√2, √4, which is 1/2, whatever you say. So you will get the answer is 1/2 for a. Or there could be many different ways, I mean, in that regard. Inverse function. So since we got a now, what is the method of finding inverse function? What is a? Let's write it from straight. A was 1/2 to the power of x. Now that's our function. As a method, we swap x and y values. So it's 1/2y, and it's 1 mark, and leave y alone. Basically, y is equal to log 1/2x. That's your 2 marks. So first step, you swap x and y values. Second step, we have to use log because it's an exponential function. Inverse of exponential is logarithmic functions, you know that. Now determine the values of x, which its inverse is more than -2. Now, let me write the equation with the function. So we are looking for basically log 1/2x is more than -2. You know what? You can first find when does it become -2 anyway. So like if we look for when is it equal to -2, when. So how do you find this? It's like that idea of jump. You can find x by writing 1/2 to the power of -2. Calculator will give you 4. Actually, that is the point given. You see, -2 gives me 4, and 4 gives me -2 in that regards, because the inverse function. Now, we didn't draw. Actually, they ask us to draw in 7.5. That means you can have a better idea when you draw after that. Let's draw it and say our answers. So I will draw that, not necessarily, but just to have, that's y is equal to x. And the line we will be drawing must be, let me take green, must be reflected about this line. So the point will be, so it will be touching where they intersect, yes. And the x-intercept is there. So what are my critical points is basically here. So this y-intercept become my x-intercept, and that point P becomes a point here, and that point will be what? -2 and 4 will become 4 and -2. See, that's 4 and -2. So that's -2 and 4. So that is critical points. And here we have like 1 and 0. Sorry, 0 and 1. It becomes in the inverse function. So 0 and 1 are y-intercept become 1 and 0 in its inverse. So what are we looking for? Now we make the drawing when we need to have that inverse of x. So we need to find when this value is more than -2. Okay, as you see, the graph is going down, and it is -2 when x is 4, yes. So am I going to write less than 4 or more than 4, or how can I properly write the restriction? Now, it must be more than -2. I will shade it on the graph to get the full answer here. So it is more than here, the shaded red shaded part. So that is the section of the inverse function when it is more than -2. So how can I write that answer then? I can write that answer by, there's a limit. I can't take more less than 0. It must be more than 0, which must be equal, not equal, which must be more than 0. And in the equation, it's just more, so it's even more than, I mean less than 4. So that interval is what I want. So that's the part section of the inverse function when it is more than -2. See, I made a clear understanding after drawing, which I had to draw in the later on questions anyway. So you can do that. Like, and then 7.4 we haven't done. It says the equation of f inverse -x. It's just actually reflected about, say, if x change, it's reflected about y-axis. You can change it in the graph and just write the equation. It doesn't say the simplest form or anything. So we already know the inverse function. So we can just substitute x with negative. So it's going to be log 1/2 and -x. That's it. Because we already know it's log 1/2x. So wherever there is x, we put -x. Do we need any restriction? Any? No, nothing. If they ask to draw, or they didn't ask to draw G, okay, we could even draw that. It will be reflected about y-axis. That means it's the all the way. Let me just draw with a slide. Yeah, like the line that this will be the graph of, will it be touching? No, that will be the graph of G. See, they didn't ask to draw G, but if we ask to draw G of x, oh, it's not touching that line, so that's why that's okay. That looks better. So the line that I draw is actually G of x, which they didn't ask. I just give this extra information because reflected about, you can say it's reflected about y-axis. So that's how I just draw like that. All right. Let's see, is there any other question that we can solve in time? So there's a parabola and a straight line, the coordinates of A, B. So intersection points, we will equate the graphs, okay? So let's just write that thing and then solve it. I'll put a smile, you can do it yourself. Inverse of a straight line. Okay, that's the same idea, swap x and y. So, and then leave y alone. You see that method is a common method now. We already know g of x is y is equal to -2x minus 3. So you will write x is equal to -2y minus 3. And from there, just leave y alone. That's it. So what's going to be, I can take 2y this side. So it's -x minus 3. And then y is equal to -1/2x and -3/2. So that's my inverse function then. Okay. For the second question, you just leave x and y alone. Sorry, you just swap x and y and leave y alone. And oh yeah, we asked this inverse, we already done in the previous question. Is there a restricted domain? Now, oh yeah, they ask it here. Because when we ask to find the inverse, we actually need to write, okay, plus minus root minus x, okay? Now, if you write plus minus root minus x, that is not a function. Okay, they ask it there. So that should be our answer if there is no restriction already in the domain. So in the questions 4.4, you say no. And what is the answer for this no? What is the reason for this no? You can say vertical line test fails. Vertical line test fails. What's vertical line test, by the way? So whenever you draw a vertical line that touches twice, which we don't want. So the graph we have, f of x is like that. Yes, this is given. And its inverse graph is like this. Now the red line is f inverse. So the vertical line is basically the line that you draw anywhere and it touches twice. It shouldn't. That's the problem. You see, this yellow line and the red line touches twice. That's what we mean vertical line test fails. And that's what f of f inverse of f doesn't become a function. And that's why we choose one of the options as a plus or minus, okay? Otherwise, as it is with plus and minus, it is just not a function failing, not satisfying the condition. So the one above part is root negative x, and the one below part is negative root negative x. We have to choose one of them. One of them is positive, one of them is negative. One of them must be chosen. And that choice can only be done if we restrict. You see, if we take the negative side of the inverse, then I can tell you it's like the fish condition, I can take it negative, or other way around, the bird or the fish. Last one, this proof question. Let's see, there is a g of x. Do we have the functions already? Let's just check above. Yeah, it's minus x squared and 2x minus 1. So let's write it. G of x is 2x minus 3, and f of x is x squared. Okay, so let's just write that aside. F of x is negative x squared, and g of x is 2x, negative 2x minus 3. Now, yeah, so how can we solve it then? Or how to also prove that question? To prove that questions, the idea is we have a left-hand side, okay, and then there's a right-hand side. So as you see, both left and right-hand side doesn't look nice, like disgusting, you know. So we have to fix both and end up the same thing. So we need to simplify and simplify. So both sides must be simplified to the same thing when you make these algebraic operations after simplifications. Okay, so it must be simplified and it must be simplified. So simplified forms of the left side and the right side must be equal after you finish your algebra. So our time may not be enough to complete that, but it's basically, let me at least write the equation. So minus 2x minus 3 as g plus 2 times it is negative, okay, negative 1 over x squared, because square of that. All right, so it's negative 2 plus 3. And then the right side is going to be, so I can take left-hand side. So I need to simplify this. I don't know how many steps it will take. And then the right-hand side on the other case, it will be 2 over negative x squared, yes. And there is negative, in brackets, negative 2 times negative x, okay, negative 3, and there's another negative 3. It just doesn't look, with these negative 3s and stuff, doesn't look very, very nice. Just be careful you are writing the functions correctly. If you write this step, that first step correctly, you will be ending up correct simplified forms, and then the proving will be done. Okay, so all is fine with these function questions for today. I hope you learn or remember what you already knew, and all the best in this section.